Welcome. One of my favorite problems, and the reason is because for some reason when I was in high school, I was so bored in my math class, I decided I wanted to memorize the square root of 8. Now, the square root of 8 is actually an irrational number, so it's impossible, but my calculator only at that time could do, the 5 digits. So I memorized that, which the square root of 8 is 2.8284271, and I've still memorized that. I don't know why. Actually, maybe the first 7 digits, but either way. It's nothing that you'll ever have to know really in your lifetime because you can always use a calculator. But if we wanted to go ahead and solve this, and I want to be able to find, we're not going to be using approximations, and that's what I was doing in my head, was trying to memorize the approximations. And in mathematics, it's very important for us to be able to use exact values. So what I'm going to do for here, though, by applying the square root method, is I'll add 8 over here. So I have 8 equals x squared. And then again, I take the square root. And a lot of students always want to jump at, oh, just plug my calculator, square root of 8, 2.8284271. But in mathematics, whenever we introduce square root, we want to make sure, of course, we also include the positive and the negative value of this. But we want to see how can we simplify the square root of 8. And the way that we can simplify the square root of 8 is by rewriting it as a product of a squared numbers, which would be 4 times 8, which I can rewrite this as 2 square root of 2. So therefore, in this example, I have x equals plus or minus 2 square root of 2. Now, obviously, if you're trying to actually approximate where actually the zeros or the x-intercepts are on a graph, then using the approximation 2.284271 would actually work. Just in the general sense, mathematically, I'm going to leave it as the exact answer for solving this quadratic by using the square root method. Thanks.